All right, ladies and gentlemen, let's go. All right, for lesson 71, we are going to talk about ellipses today. All right, for those of you who need a visual aid, okay, it's more or less looks like a football in some way. All right, now this would be an example of an ellipse here. All right, there are some characteristics to it that make it different than what is this shape here? A circle. What is the basic equation for a circle? X minus h squared plus y minus k squared equals what? The radius squared. That's right. Okay. Now, the reason why this equation works, okay, is this equation works because the radius is consistent throughout. Now, there are a lot of the same characteristics, Maxwell, of an ellipse as there is with a circle. But the biggest part is that the radius is constantly changing in this, okay? As you can see, if we've got the center approximately there, all right, this distance is very different from this distance, okay? Now, because of that, we have to change the equation just a little bit too. All right, now the things that stay the same. This x minus h squared is going to stay the same. Plus the y minus k is going to stay the same. That is always talking about the center of either one of these two objects. Okay, so that stays the same. Now, normally, if it were a circle, normally we'd say that's equal to r squared. Okay, because the radius changes, we have to adjust this equation just a little bit. One way that we're going to adjust it is we're going to have it set equal to 1. All right, but each one of these two terms has to be divided by something. All right, and just to make it simple, we're going to call it a squared and b squared. All right, now that a and that b are important because what it does is our a measures from the center to the outer edge horizontally. So you can either go from the center to the left or the center to the right. Okay, and our b would be from the center to either the top or the bottom. Okay, all right, now one way to look at this also. Okay, and I don't recommend you remembering it this way, but say that we wanted to go back to our circle equation. Say we divided everything by r squared here. This turns into a 1, doesn't it? All right, and then this would be the distance from the center to the horizontal outside edge. This one would be from the center to the top. So technically they are doing the exact same thing here, all right? But for a circle, we don't do this part because we don't need to. We already know that whatever it's equal to is going to be the radius squared. Okay, so how do we do this stuff? All right, so we've got an equation here. X squared over 36 plus y squared over 9 equals 1. All right. First of all, we want to get it on the graph. We'll talk about this focus thing in just a little bit here. All right. Now, most important part, just like for a circle, we have to find the center. What's the center of this ellipse here? 0, 0. We don't have anything added or subtracted onto our x's and y's there. So it's just 0, 0. All right. Our a value is going to be the square root of 36, which is 6. Our b value is 3. So what we do then is we put our center in there, and then we count to the right 6, to the left 6, up 3, and down 3. And then do the best you can to draw in an ellipse here. All right, so something similar to that. All right, and that is it for graphing out an ellipse. All right, any questions there at all? Okay, now what we will see later on in some of our problems is your first step for this is, remember when we factor, you have to have it set equal to 0. When you are doing an ellipse, you have to have it set equal to 1. So if it's not set equal to 1, you got to make it set equal to 1. All right, now to find the focus here. All right, there is an equation for this, but let me kind of explain the concept of a focus first of all. All right, if you remember, we talked about a focus a little while ago with a parabola. All right, the focus is on the inside, and then you have this directrix on the outside. And what we said with that was the distance from the focus to any point on the parabola is the same as the distance from that same point to the directrix. So we'd say this distance is equal to this distance. If we're talking up here, that distance is equal to this distance, and so on. Okay. Now, in an ellipse, we also have the same concept, but we would actually have 2 of them. All right. And we're going to figure out exactly where it's at. But the main thing is, first of all, it is always on your major axis. Your major axis is just the axis that's the longest one. So our major axis here would be our x-axis here. And let's say that they are approximately right here. They're always the same distance from the center. All right. And how this works is, if we were to pick, say we were to pick this point here, for example, and we found the distance for each one of those 2 lines there, and we added those 2 distances together, that distance would be the same as if we found the distance from this focus to that point plus this focus to that point. The distances would be the same for the whole thing. All right, and it would be for the entire object here. Okay, so for those of you who like to do some of this visual stuff, have to do it with your hands. All right. Our Coach Safe asked me a while ago, he's like, all right, I'm trying to build this thing and I need some help on how to figure it out. So he was building this thing and his platform kind of had a curved edge like that. And I'm like, all right, that looks to me like it'd be about half of an ellipse. All right. And he's like, I want it to be perfectly symmetrical for the whole thing. All right. And I said flat out, all right, here's what you do. And he told me the dimensions of everything. And I said, all right, you are going to measure from the center to this spot. And I told him the exact measurement. And then you're going to measure down that exact same distance. All right. And then I said, what you need to do is you need to cut a string that is exactly however long the distance is. Have one of your kids hold the string here at this point, have the other one hold the string here at this point. And then what you need to do is maximize, like there's going to be some leg in the string then. If you max that completely out and draw inside that string the whole way, you're going to have what should be a very close to a perfect ellipse. All right, and that's how the focuses get used. All right, now the equation to find the focus. All right, we are going to use our A value and our B value, and what we're going to have here, let me get rid of this stuff on here so you can kind of see what we're going to do. We're going to draw in a triangle here. All right, so we're going to say the focus is approximately, we'll go positive, so we'll have positive values here. All right, we're going to draw in this triangle right there, okay? For that triangle, things that we know for sure. Now, first of all, we don't know this bottom part here at all, okay? We're trying to find that. But we do know this part here on what's called our minor axis. That's just our smaller one. For this one, this would be a triangle with a height of 3. All right, the other thing that we know is we do know our hypotenuse. Our hypotenuse ends up being 6. All right, and the reason why is if we were to attach that string to both of these foci here, we would be able to stretch it all the way out to this very edge point. So our hypotenuse is always equal to whatever our bigger one, the square root of whatever our bigger one is here. All right, to find this, we're just gonna have to do Pythagorean theorem, right? So we would have x squared plus 3 squared equals 6 squared. So 36 minus 9. So x squared would equal 27. We take the square root of that. All right, and our x value for the foci are going to be whatever 3 square root of 3 is, okay? And that would be on either side of the center here. So this would be a plus or minus 3 square root of 3. And then our y value would be whatever the y value of our center is, which is a 0 here. Okay. All right, so we'll do another one of these in just a minute. I know this is a new concept here and it's a little weird. Okay, Carissa. Right here? You don't. I just put in an example here. All right, but the biggest part is we're going to draw a triangle in here. And the things that we know the vertical distance is 3. We know the hypotenuse is 6. Then we can figure out what this is. Okay. It is always whatever the square root of the bigger one is. Okay, that's all it is. All right, so clean slate, we'll do another one. We're going to graph it and we're going to find the focus here. Yep. All right, so 3x squared plus 7y squared equals 14. First step is to do what here? What's that? Yes, we have to get it equal to 1 here. So we're going to divide everything by 14 here. So what this means is we're still going to have an x squared on top and a y squared on bottom, or y squared on top equals 1. We've got to figure out what number is going to go below here. All right. The easiest way to find out what number, we'll start with the y because it'll make a little bit more sense. Okay. To find this number that goes underneath, take 14 divided by 7 is 2. Okay, now think about that. If we had 7y squared over 14, you guys would all be able to say, all right, 7 goes into both of those. We'd have a 2 left over on the bottom. But to get this, all you really have to do is you have to go the bottom one divided by the top one. So then for the second one, or for the x, the number under x then, we would go 14 divided by 3. All right, and we can you can write it as a fraction if you want to. You could write it as a decimal if you want to. It doesn't really matter here. Either one of these would be correct. All right, because all we're trying to do here is we're trying to graph this. All right, so our center is still at the point 0, 0. Our a value is whatever the square root of 4.66 is. Which is 2.16. And then our b value is just the square root of b, which is 1.41. All right, so that is what we're going to label out here on the graph. Center is 0, 0. In the x direction, we're going to go over a little bit over 2 in both directions. Y value, we're going to go about 1.5. And then we draw in our ellipse. Now, this one doesn't look nearly like the ellipse from the last one because our A and our B values are so close together. All right, now, this one doesn't say it, but I want to try and find the focus also. Okay, now, our A value is bigger than our B value, so we're going to have another triangle that was just like the last one here. All right, our B value is our height, so 1.41. Our A value ends up being equal to the hypotenuse in this triangle. All right, so then you just do Pythagorean theorem to figure out that x squared would equal 2.68. And then you take the square root of that. And we find that our focus values are equal to 1.64. All right, now because this is another one where the major axis is the x-axis, we're going to add and subtract that to the x value of your center. So that means our foci are at the point plus or minus 1.64, comma, 0. So those would be, I don't know, maybe about there and there. Okay. A couple of things, like I said before, with the foci, it is always on the major axis, so whatever one is longer. Okay, and it will always be on the inside of your shape. So if you do the math and it gets to be on the outside, you messed up somehow and got to go back and try and fix it. Okay. The foci, if you were to attach a string to both of these and extend it out as far as you could, it would give you a perfect ellipse, both on the top, and then if you attached it and stretched it out on the bottom, it would also give it to you on the bottom too, because the distance from here to here plus this to this is the same distance as, say, this point here, this distance plus that distance, and it would be the same for every point on the ellipse. All right. All right, any other questions here, guys? Ethan, still with us? You sure about that? Yeah. Okay. All right. One more here. I don't remember if this, that's what I thought. Last one for this lesson. All right, so this one's just a little bit different here. Okay, this one, we're just gonna graph the shape to it. All right, so our first step is to do what here? We got to divide by 12. And then simplify out this equation. So we've got x minus 3 squared plus y plus 2 squared equals 1. What is our number that's going to go under the x's here? 12 divided by 2 is 6. Under the y's, 12 divided by 3 is 4. All right. So our center is at the point 3, negative 2 then. All right, so this one moved a little bit on us. You do all the same stuff though. All right, our A value is whatever the square root of 6 is. Which is 2.45. Our B value is the square root of 4, which is 2. All right, and then with those, that's how much you're counting. Remember, a value you're counting right and left. So 1, 2, about 2.5. And then our b value is how much we're going up and down. So there's 2 and there's 2. All right, and this one's going to look really close to a circle here. All right, you can see that this one's a little bit wider than it is taller. All right, but that's it. All right, questions at all? All right, we'll go on to 72 then. 72, you guys have done a few times already. I know we did this last year in Algebra 2, and you guys did it back in geometry also. So, but this one is, you could look at it as a little bit more fun because you're trying to find the pieces to the missing pieces to the puzzle here. All right, so there are a lot of steps to this though, or potentially, because there can be so many missing items here. All right, law of signs. Law of signs is when you are trying to find missing pieces to those triangles. All right, the biggest thing to know that you can use the law of signs is you have to have an angle and a side working together. You have to know both of those. All right, if you do not have that, you cannot do law of signs here. All right, but if you do have that, then we can use the law of signs to find our missing pieces here. All right, so as you guys know, this angle and that side work together. Our angle Y and side A work together. We don't have either one of these, so it's going to be really hard to use law of signs with those right now. So we're going to have to use our angle X and side 14 first to be able to solve this. All right, and this one is just a ratio. All right, it doesn't matter how you set it up, as long as you set it up proportionally the same way every single time. So what I'm going to do is I'm going to put the side length on top over sine of the angle that it's working with, and that is equal to the side length over sine of its angle that it's working with. Okay, and then from there, to solve for x, we've got proportions here. We can just cross multiply this. So 8 sine of x equals 14 sine of 26. To get x by itself, you guys know, first of all, we got to divide all of this by 8. And when we do that, we get a sine of x equals 0.767 approximately. Okay, now it is very important for these to not round. All right, this is rounded so that I can show you what I'm doing, but when I use this in my calculator, I'm going to use the entire decimal here. All right, so then to get x by itself, we're just going to move the sign over to the other side, and that's going to be using sine inverse of that decimal. All right, so sine inverse of that would get us x equals 50.1 degrees. Now, once we have that, sometimes we're going to be able to find some other pieces without doing law of signs every single time. Like for this one, sorry about that, give me a second here. For that one, we can find what other missing piece. What can we find? We can find y very quickly, right? because what we know is we know that the three angles together have to add up to 180 degrees. So if we just go 180 minus 50.1 minus 26, that will give us our y value. And that would be 103.9 degrees for our y value. And then once we know that one, then we can go solve for a yet, okay? Now, because this is not a right triangle in any way, we're gonna have to use law of sines again for this, all right? What I would do to make sure that my answer is the most correct, this first ratio that we have here, those do not have any rounded values in here. Technically, you could use the 14 and the 50.1, but this is already a rounded value. If you use a rounded value to get another value, this value is going to be just a little bit more off. Most of the time, it's going to be very, very similar, but it's going to be further off for it. So I would use the one that we are given here. So if we do law of sines with that, we're going to go 8 over sine of 26 equals, our side length is a over sine of 103.9. And then we do all the same stuff. We're going to cross multiply here. And then this time we're going to try and get a by a by itself. So we are going to divide by sine of 26 here. And this time that will give us our answer for a, which ends up being 17.7. All right, now, one thing that I do to make sure that I have things, things right up here is I do a quick check. I make sure that my smallest angle corresponds with the smallest side. My largest angle corresponds with my largest side, okay? If that is not the case, then obviously there's something wrong with it. Okay, other than that, there's not a great way to check other than the three angles have to add up to 180, other than just redoing your math again one more time. All right, now on the last one, what we had was we had two sides and an angle. This time we have that exact same concept. So what I want you to do is I want you to go ahead and find Z, F, and A, please. What you're going to need to find first is you're going to need to find a F. Is that what you got for F? Now, what seems a little bit off there, though? What was that? What was that, Paul? Yeah, we have an obtuse angle here. and we had an acute answer for this. What are we going to have to do to be able to get the right angle here? What's that, Max? Close, not quite. Right. For sine, remember with our sine wave kind of looks like this. Remember, this is 180 here. If you were to look at, say, 120 and 60, they would be at the exact same points here. All right, so what we can do here is this is our reference angle. If we go 180 minus 33.9, we would be able to get the correct answer for this, which would be 146.1. All right, you should be able to figure out the other pieces now. All right, any questions that you guys see with what we're doing up there? Do you guys remember doing this in the past? All right. All right, now I'm just gonna show this to you really quick. You don't have to write it down. Okay, for this, all right, if you can find something really quick, do it. Okay, when we have two angles here, that is more than enough to find W, right? Because we just add these together, subtract it from 180. There's our 110. Okay, and then to find our A and our B value, we're just going to have to use our 7 and our 30 with sine law to find our A value, and then do the same thing to find our B value. Okay, so you don't have to, you don't have to use sine law to find every single one of these. If you've got a shortcut to be able to find these, do it. Okay, all right, so just wanted to show you that really quick. All right, now this one, if you look at that, can we use law of sines to be able to solve this triangle? Why not? Yeah, we don't have a side and an angle that matches up here. All right, so this is one that today we are not able to do. Okay, we will, there's another law out there that's where we do use it to be able to solve for this one, which we'll do on another day. All right, so any